Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Next installation, again about the vectors. But I will deal with vectors a little bit differently than previous two. Previous two, we were working through triangles. We were solving sine law, cosine law. We were reversing the direction of the vector. And it was all fun. But more often than not, you will have a different method. And that method is related to coordinate system. Okay, so we can put our coordinate system any way we want. We can put this is y, and this is x, and this is horizontal, and there is a ball flying or something. We can say there is incline, and on this incline there is body, and yes, we can still put x this way and y this way. If we want, we can put x this way and y that way. It's our choice how we direct our coordinate system. Moreover, and quite often it's very useful, we can put x this way and y that way. And it's fantastic, and the body goes down and accelerate is very convenient. But it also may be useful for us to put y here and to put x here. This is in the case, for example, when there is some other force that pulls the body up and body accelerates this way. Then we want to put x this way, and then we will know that A would be positive. But A may be free-falling body, but it may have original speed v0. So v0 will be up, but A will be down. A would be directed this way. So we put the coordinate system this way, but then we will have to keep in mind that A is directed against x. So I'm a little bit maybe running ahead of me, but what I'm trying to say is that if we have one vector, A, remember I was telling you two things. One thing about the vector, that vector is defined by two things, by its length and by the angle. So we have this vector A, and we have this angle theta, and so we can say, yes, this is a vector, but we also can say this, let's do projection of this vector. Projection here and projection here. And then we will say that this would be, let's extend it. The x would be this. And then we say that this would be ax, and this would be ay. And we can say that instead of the length and the angle, we can have ay and ax. Let's draw this picture a little bit bigger because it's suddenly crowded. Let's say this is a vector, and let's say this is the angle, and this would be a projection, and this projection would be ax, and this projection would be ay. And then what can we tell? We can look on this triangle and we can say that this is A, and this is a rectangular triangle, and this is theta, and this is ax, and this is ay. And just looking on this, we can say many things, and you have to be fluent with this too. You have to be fluent now with sine and cosine, and this leads us in tangent, because all you have to remember that if we have a rectangular triangle, then AY divided over A is called sinus theta. And AX divided over A is called cosine theta. Those things you have to remember. You have to memorize something at the very beginning, and I suggest that you memorize those two things. Right? There is no way around that. This side close to the theta divided over hypotenuse, this would be this side, and it is AX, and it divided over A, and it gives us cosine. And this side, opposite of the theta, divided over A, it's sine theta. And you have to remember this, and maybe I will give a special section on this. But for the time being, I probably will give the next clip talking about all this in a little bit more details, because I don't want to overwhelm you here. But for the time being, all we can say that if we multiply A here, we will have the same AY equals A sine theta, and AX equals A cosine theta. So again, there are two choices for us. We can have the length, which is here, this is the length, right? This is the length, and we can have the angle. And this is vector, like an arrow. We can completely forget about this as arrow, and we can say that those are two independent numbers. One is this number, and another is this number. This is a projection on one axis, this is a projection on another axis. We can choose the axis the way we want, and we deal with this. For example, we could choose those axes like that, and then the vector would be straight here. This would be y, and this would be x, and in this case ax would be a, and ay would be 0. But you may say, where's the angle? The angle now is hidden in the way we choose the system of coordinate. But if we choose normal system of coordinate, horizontal, vertical, then it's just straightforward. The angle, the length, and two projections. And of course, and I show you how to receive, if we know this and that, we can resolve this against those two. And let me do it in the next installation, because it's kinda, don't want to rush things. All I wanted to tell here that there is a vector on the surface, two-dimensional surface, defined by its length and by the angle theta. We can to switch it to the system of coordinate and say one projection is one thing, another projection is another thing. And so two projection defines the vector. Either way, two things, 2 degrees of freedom, they call it in physics, defines the vector. Okay, I will put this there, so I will start my next video with this, that I moved here, I don't need a sine law. And next video would be discussion of this triangle. What is sine, what is cosine, which is tangent, how to solve this against A and theta. But to see this video, you need to like, you need to subscribe, you need to bell, then you will get notification when I upload it, and you will watch it, and meantime ask your question, write a comment, write a problem. And see you next time. Thank you very much.